This video will take a look at using lldb on the Mac. This is the debugger that's built into the Mac, and you don't have to go through the setup that you do with GDB. So that's one of the big advantages. I find GDB to be a little bit more user-friendly, easier to use. However, on the Mac it's a little flaky, as you've seen. So lldb will work well, it'll be less flaky, but I find it a little bit harder to use. But let's take a look at how it works. So I have my implementation of program 3. We can run it with 3 arguments, and we see that it has a bug. We do hex dump, we can look, and we see that there just isn't anything coming out between the hello and the exclamation mark. So it looks like it's finding the 3 arguments, but for some reason it's not printing out the arguments. So let's debug it. Now, when I compiled this program, I used this -G option to do the compilation. You don't have to do it, but it will make the program show up a little bit nicer in lldb if you compile with the -G. So let's run it. We run it just like we do GDB. We do lldb./ and the program name, and we set a breakpoint in main, just like you do with GDB. And we run it just like you do with GDB, right? So, okay, and here we see the program. Now, because we compiled with -G, we actually see the source code of our program, which is kind of cool. So we see their comments and everything. And we can look at things, and this is mostly like GDB as well. We can say RDI, and we can look at RDI. We can look at RSI. So RDI is the number of arguments. We see that's right. We can look at RSI. And of course it prints as decimal. That's not what we're interested in. We want to look at the address version of RSI. That looks like an address. We can actually use X. X works a little bit differently in lldb. It works in a way that I really like. So this will show us the memory at the address contained in RSI. And here we see these look like addresses, and we can even check it out. So we can say x 0x 7f, so we just have to reverse this, right? 7f FEEF, right? 7f FEEF BF FC 48. And there you go. That's the program. We can do it again. We see that this is BFFC72 for the next one. So we do 72 here, and there's the Ben. We see the null. So yeah, this looks good. So we're off to a good start. Now, it'd be really nice to do something graphical. This doesn't look as cool. If you type GUI, you can go into this graphical view. Press any key to escape that first one. Now, if you push escape, it will take you back to your lldb command line, and if you type GUI again, you get back where you were. So here we can change our view. Like there's the variables thing at the bottom. We don't care about variables. So we can do F5. You might have to hold down the function key for F5, and then hit V for variables, and the variable screen will go away. But we would like to see the registers. So you do F5 and you do R for registers, and now we have that register screen at the bottom. And if you push tab, you can move between these screens. So on the register screen, we can push the right arrow key, and that will expand that little general purpose registers. So let's go up to, we push tab to get to our source again. And we're seeing we're saving some things off. So I'm saving the count into memory, into the argc in memory. And I'm going to save the address of the args list into argv. So we'd like to step to the next line. So if you push H, it shows you the hotkeys we can use. If you scroll down, we have this lowercase s and capital S, single line or single instruction. So let's step single line. So we can just push S to step to the next line. Okay, so here we are, stepping through the program. Everything looks pretty nice. So now we're coming to our first decision. Now we actually know this works because we saw 3 lines of hello print out. So RDI is the count. It's currently at 4. We can see that down here. And we step over it, or we subtract 1 from it, and it's still non-zero, so that means there's more to go. So we jump to our print loop, and we print the hello. Now we've seen the hello print okay, so let's go through that. Now, this is probably where it's broken, because this is where we actually print the argument string. So we load argv into RSI. Okay, for some reason my registers went away, so let's tab over there, open them up. So RSI would now contain argv. We're going to get the index and we're going to multiply it by 8. So we kind of prime RAX with 8. We set RCX to be the address of index. We're doing multiplications. We need to set RDX to 0 because it's going to get changed. Actually, that doesn't really matter. But and now we are going to multiply A by the index. Now note here there is a bug. This is, or maybe not. I believe you can actually push the up arrow key to move up through the source. Index is actually quad word. So this is a bug because we should really be moving the quad word index in, but because we're little Indian, it still works, right? Because everything's stored backwards. So so that shouldn't cause us the problem, and we can actually see for sure. So here we look at our RAX and it's 8, right? That's the offset we want. We add that to RSI, and then we get the address. We get what the content of that index in the args list, and we move that content into RSI. So now RSI should be pointing to the first string. Now we can push escape to get back to the command line and look at that to make sure. So let's look at what RSI is pointing to. And sure enough, we see the hello just popped out. So let's look at RSI one more time. And there is the Ben. So yeah, that's the first argument. That looks all good. Let's go back to our GUI. So we know RSI is pointing to the right thing. Now I'm copying RSI into RDX because I'm going to step through looking for nulls with RDX. So we're doing that. Oh, we're setting RAX to 0. Now you'll notice when we left the GUI and went back in and came back, it reset our view. So we want to get rid of the variables, do the registers, tab over, open up the general purpose registers. Yeah, so we're setting RAX to be 0 to help with debugging. We want to clear it all out so that when we're looking, we're going to start playing around with AL because we're going to look at each individual bytes with the AL register. So if we make all of RAX 0, it just makes it clear what we're looking at. So yeah, now for some reason, at this point, it jumps away from the source. So it's looking at it's looking at the compiled code, which is fine. It's just, the backwards version, and this is kind of a flaky thing. I don't know why lldb did this to me, but it's still our code. So we're moving into, let's open the registers here. So we're moving what RDX is pointing to into AL. So we see here that the 62 gets moved in. That's B, right? Which is not 0. So we are going to go to the next one and compare again. There's the E. Okay, so, and there's the N. Keep looping through, and there is the null, right, the 0. And so that's going to get out. So I don't know why it jumped out of our source debugging there. But we're back looking at the source. Okay, now we set up the RAX register. We set up the RDI register. Now we're, according to our source, our comments, the RSI and RDX registers should already be set up. So let's just look at that. So RSI looks right, that's an address. But your RDX, the RDX is also an address. This is the address that we left off at. So we've forgotten to do something. In order for RDX to be set up, we need to do a subtraction. So we need to do that now. And so that RDX is a very large number, and I think that's why the write is just failing, and that's why nothing's coming out. So hopefully that's clear. This is supposed to be 3. Now if we subtract RSI from RDX, we will get 3, because RSI is the start of the string, and RDX is the address of the end of the string. So we just have to subtract off the start of the string at the beginning of do write, and RDX should be set up correctly. So let's exit out of here. And let's edit our code. So that was a lie. The comment was a lie. But it was kind of good, the comments there, because it was very clear what got messed up. So it's right here. Where does it say they should be set up? Let's go down a little bit farther. Right, RDX. So we need to make sure that RDX is set up properly. So we want to subtract from RDX RSI. That should do it. Let's see. We'll compile it. We'll compile it with -G just in case we need to debug it again. But I think we got it. So Ben, Amy, Tanya. Boom. That worked. So give it a try. You might like it. lldb is the one that's built into the Mac, so it should be easy to get started with. Okay? Hope this helped. Good luck.